Hello everyone, welcome to Amaze. In this video, we are going to start with chapter number 5, Arithmetic Progressions. So basically in this video, I will introduce you what is arithmetic progression. Right? So let's begin. Let's say if I am having a list of numbers like 1, 3, 5, and if I ask you, let's say one more number 7, and if I ask you what will be the next number, will you be able to answer? Look here, 1, then you are having 3, then you are having 5, then you are having 7. It's nothing but the number is getting added by 2, right? The succeeding number is getting added by 2 if you look at the preceding number, right? So 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, then 7 plus 2, obviously it will be 9, right? Next will be 11, 13, 15 and so on, right? So you got the pattern here that it is nothing but addition of 2, right? Now let's say if I am having this particular pattern, let's say if I am having 2, then 4, then 8, then 16, then will you be able to predict the next number? Yes. You can look here, this is 2 into 2 which is 4, 4 into 2 which is 8, 8 into 2 which is 16. So 16 into 2 will be 32. So here you can look at the pattern which is nothing but it is getting multiplied by 2, right? So now here you have seen two patterns. One is nothing but addition by 2 and one is by multiplication by 2, right? So these are the two patterns. Now what do you mean by arithmetic progression here? So look here, the different patterns which you have observed here, out of this, if it is just addition or subtraction by a number, then that type of pattern is known as arithmetic progression. So this is an arithmetic progression, right? And this is a different progression which we are not going to see in this particular chapter, okay? You will study it in your further grades. So let's focus on this type of patterns where it is addition or subtraction by a particular number. Now let's look at the definition of arithmetic progression. So arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number. By adding a fixed number can be positive, negative or 0. By adding a fixed number to the preceding term except the first term. So except the first term, look at all the other terms. It is nothing but it is getting added by a fixed number to the preceding term. So here 1 plus 2 which is 3. If you want to obtain the succeeding number, let's say the third term, you have to add a particular number or a fixed number to the preceding term, right? Which is 3 plus 2 here, 5. Clear? Now, what is this fixed number called here? A particular terminology is used. The fixed number is called the common difference of the AP. Arithmetic progression, in short, we write it down as AP. Arithmetic progression. So the fixed number, this fixed number which is getting added, okay, that is nothing but it is called common difference. Common difference. And common difference can be positive, can be negative, or it can be 0 also. Okay, let's say if I am having a particular pattern as, let's say 25, 20, 15, 10 and so on. So you can look here, what is done here? It is getting decreased, right? So here the common difference is nothing but minus 5. Okay, why minus 5? Because we calculate the common difference always succeeding term minus the preceding term. So here it is 3 minus 1 which is 2, 5 minus 3, which is 2, 7 minus 5, which is 2, right? And so on. So here, what is 20 minus 25? It is minus 5. What is 15 minus 20? It is minus 5. So your common difference here is positive, and for this particular arithmetic progression, it is negative. Okay, and let's say if I have a pattern like 3, 3, 3, 3, and so on. Is this a arithmetic progression? Yes. Here the common difference is nothing but 0. If you add 0, then you are going to get the same number, right? Or subtract 0. So here the common difference is 0. So in arithmetic progression, the common difference can be positive, can be negative, or can be 0, right? Now let's move on to the other terminology, which is, okay, let me write down one of the arithmetic progression here. Let's say if I am having this 3, 6, 9, 12, and so on, right? Now here a particular arithmetic progression, whatever it is, each one of this are called terms. Okay, are called terms. So how we name it as, this is how we call it as, this is first term, this is second term, this is third term, this is fourth term, this is fifth term. So each one of them, the list of numbers, then each number is called a term in arithmetic progression. So here, what is the second term? 6. What is the fourth term? 12, right? So now let's move on to the other terminology, which is finite AP. So look at this, 3, 6, 9, 12, and look at this. If I write down in this way, 1, 3, 5, 7, 9, and so on. So what is the difference here? Look, here I have written 4 terms and then I have ended the progression. So this type of AP is known as finite AP. Finite AP, because you have finite number of terms. Finite AP, right? Finite arithmetic progression, because you have finite number of terms. Here, will you be able to answer how many terms are there? No, right? Because it is on and on, right? 1, 3, 5, 7, 9, and so on. It is not ending anywhere. That means this type of AP is known as infinite AP. That is infinite arithmetic progression. Clear? Now let me again summarize quickly. We can have multiple number of patterns, like each number is getting added by 2, each number is getting multiplied by some number, okay, added by some number, multiplied by some number. That is the different patterns we can have, right? Adding or subtracting, multiplying or dividing, okay. Now the progression or the pattern where you have a fixed number getting added, it can be negative, positive, or 0, right? A fixed number getting added, that type of progression is known as arithmetic progression, okay. So we are not going to look at this type of progression where all the terms are getting multiplied or divided by a particular number, right? So arithmetic progression clear? Now, yeah, let me write down to be for you to be very clear, this is not an AP, right? Because there is no particular number which is getting added. There should be common difference, then only we can say it as an AP. So what is the difference here? You can look between 4 and 2, it is 2. Here the difference is 4, then 8. So the difference is not same. Therefore this is not an AP, right? Not an arithmetic progression. But this is an arithmetic progression where you have the common difference. Okay. Yeah. Next thing I told is each one of them are called terms, and when you have finite number of terms, it is finite AP. When you have infinite number of terms, it is called infinite AP. Yeah, so that was the introduction about arithmetic progressions. So in the next video, I'm going to cover important questions of exercise 5.1. So that's it for this video. Thank you. Catch me up in the next video.